Scalars and Vectors. Here are your priming questions. First, let's start with some definitions. A scalar is a quantity with a magnitude only. The example here is speed. When we think of magnitude, you can think of the value in itself or its size in some cases. But this is just the value and its unit. A vector, on the other hand, has magnitude and direction, and that is important. So the example here is velocity. Okay. So let's talk about speed first, and you're very familiar with this, most likely. If you think of your car, and when you're driving in the car and you look at your speedometer, that tells you your speed. It's a speedometer. And whatever value it gives you, it's going to be in miles per hour or kilometers per hour if you look at the other scale. And so let's say you're driving down 85 and you are driving the speed limit in town. So you are driving 55 miles per hour, mph. Now, this doesn't tell you whether you're going south or northeast or southwest or just any direction. Your speedometer can only tell you how fast you're going, the magnitude. Now, if you've been watching the news for the weather, a lot of times they will tell you the wind. And when they tell you the wind, they tell you not only its speed, but also its direction. In that case, they tell you the vector quantity of the wind. They tell you the velocity. And that's going to be, in this case, 6.4 miles per hour, east-northeast. So whenever they give you a direction and the value and units, that's going to be a vector. Anytime I ask you for a vector quantity, you need to make sure to give me the number, the value, with the correct sig figs, with the correct units, and the direction. Here is a quick listing of some scalars and vectors. The ones that we're going to be focusing on for this term are going to be distance, speed, time, and energy, and displacement, velocity, acceleration, forces, and momentum. These will be the primary ones for this term. And remember, scalars, magnitude or size only, and vectors, magnitude and direction. So these all need to have directions when you give them to me. If I ask you for a velocity, I expect you to also give me the direction. So distance versus displacement. Some other definitions. Distance is simply the magnitude, so it's how far traveled along a particular path. It doesn't matter the shape of the path, it's just how far you traveled along that particular path. Whereas displacement is going to be the straight line difference between the starting and ending positions. So the position does matter. So let's do a quick example. Let's say you are at the top of this circle, and the circle has a circumference of 6 meters, and you begin walking around the circle, and you come back to your beginning position. If we are referring to your distance, how far you traveled along the path, you've traveled along the circumference of the circle, which would be 6 meters. So your distance would be 6 meters. However, your displacement is this straight line difference between your starting and ending positions. And if you start and end in the same spot, there is no difference between those. And so in this case, your displacement would be 0 meters. And there's no direction there because your value is 0 meters. Now let's look at another example. Let's say you are going to walk in a straight line. So you are on this side, and let's say you start over here, and now you walk 4 meters to the right, or we could also say east. Ooh, that is east. Now, your distance, you've gone in a straight line for 4 meters, so your distance, and I'll use the lowercase d, is equal to 4 meters. No direction, because we don't need a direction for distance. However, for your displacement, and I'll use a capital D in this case, displacement, in this case, from your starting over here to your ending over here is 4 meters. And the direction, because it's displacement, is east. So your displacement here would be 4 meters east. And that's what you would need to give me for that answer. Now, how about speed and velocity? So this goes back to the first slide that I showed you. Speed we can define as a change in distance per time, whereas velocity is a change in displacement per time. And so this gives you a hint in terms of which one is a scalar and vector. Distance was a scalar, so your speed will also be a scalar. Displacement is a vector, so your velocity will also be a vector. This is a good general rule of thumb. There are some exceptions that we'll talk about later on in the term, but this is a very good general rule of thumb. So let's give the same example as before. Let's say you are at the top of the circle, and you're doing the same thing, except now you have a stopwatch. So you're going around the circle, and you can do this in, let's say, you've done this in 3 seconds. Now we want to figure out what your speed and velocity are. And so we'll start with our speed. And if we do change in distance per time, we can think of speed as equal to the change in your distance over the change in time. Delta D over delta T. This is often just written as D over T. And so here, if we're looking for our speed, our change in distance was 6 meters. Our change in time was 3 seconds, which means that our speed is 2 meters per second. Our units here come from the equation. Just distance over time, meters over seconds, so meters per second. Now, velocity, on the other hand, it looks very similar. We can say velocity is change in displacement per time. So V is equal to delta D over delta T. And the deltas just mean change. So the change in displacement over the change in time. And so, with the same problem, our change in displacement, like we talked about before, is 0 meters. And our change in time is still 3 seconds, which means that our velocity is 0 meters per second, and there is no direction because our value is 0. So it's 0 meters per second. And that is your introduction to scalars and vectors. Here are your priming questions again.